In this video, we're going to take a look and see how to calculate areas under the normal curve and how to find values if we're given the area. So this is applications of the normal distribution. So before we start with the applications, the standard normal has a mean of 0 and a standard deviation of 1. So a standard normal is the normal distribution that corresponds to z-squares, or z-scores, 0, 1, 2. If you have below the mean, remember that a z-score was x minus the mean divided by the standard deviation. So what the z-score does is it tells you no matter what units you're measuring, whether it's height, weight, test scores, whatever, the z-score tells you how many standard deviations you are above or below the mean. So when you see a z-score of 1.7 and it says find the area of something, it tells you that you're using a standard normal distribution with a mean of 0 and standard deviation of 1. Okay? So the problems that we're going to look at are not the standard normal. We're going to take a look at items that have different means and standard deviations. So our first problem, a pediatrician obtains the heights of her 3-year-old female patients. The heights are approximately normally distributed with a mean of 38.72 inches and a standard deviation of 3.17 inches. So now we're looking at heights. So our mean of 38.72 and our standard deviation of 3.17 are drawn on this curve. Okay. Use the normal model to determine the proportion of the 3-year-old females that have a height less than 35 inches. So to solve these problems, I would always recommend draw the normal distribution. You want a height less than 35, so shade in the area that you're looking for. So what we want to do is I'm going to show you a video solution or a solution using the TI calculator. You can also use StatCrunch. If you prefer StatCrunch, there's a video solution here that will walk you through the steps in StatCrunch. So what the function is on the calculator that we're going to use, let me open up the calculator, is something called the normal CDF function. You hit second, variables, and the first two choices are normal PDF and normal CDF. Normal CDF is what we're going to use. And what it asks for is it asks for a lower bound, an upper bound, a mean, and a standard deviation. So that's what we have to determine, and then we'll use the calculator to type that in. So when you take a look at this particular graph, remember that it goes on forever and ever in this direction. So the interval that we're trying to find the area of is from negative infinity to 35. And we're given the mean is that 38.72 and standard deviation of 3.17. So the calculator, if you have an older model, doesn't have an infinity key. Use negative 1 E99. This means negative 1 times 10 to the 99th. And that's about as close to negative infinity as you could get. And then if positive infinity, use 1 E99. So let me show you where that's at. So on the calculator, lower limit of negative 1, use the negative key 1. The E is above the comma, and this is the engineering notation. It means times 10 to the power of 99. So negative 1 E99 to 35, that's the interval that we're looking for. The mean of our distribution is 38.72. And the standard deviation is 3.17. Then we want to paste, and we get an area of 0.12023. So that's this value. So we have to use the calculator to find the areas. If you're going to do this method by hand, the by hand method changes this to a z-score and then uses the standard normal and a table of values. technology is much faster and easier, so I'm recommending use the calculator or use StatCrunch. All right, so the proportion of 3-year-old females that have height less than 35 inches is approximately 0.12. Or another way to say it, about 12% of 3-year-old females are less than 35 inches tall. All right, next example. For the same problem in example 1, find the probability a randomly selected 3-year-old girl is between 35 and 40 inches tall. So we have the same normal distribution. Shade in the area that you want to find. So we're going to use the same distribution, normal CDF, and we're going to type in this time, we want to go from 35 and 40. We want the area between 35 and 40. We have the same mean, same standard deviation, and we end up with 0.5365. Okay? And we've got the normal CDF here on what to type in. Next example, what if we're given an area and we want to work backwards and find the height that goes with it? So in this case, the heights of a pediatrician's 3-year-old females are approximately normally distributed with the same mean, same standard deviation. Find the height of a 3-year-old female at the 20th percentile. So remember, the 20th percentile means that 20% of the population is that height or shorter. So what we're looking for this time is the height that goes with an area. So this is a new calculator function, okay? The TI calculator function is the inverse normal function, and that will find values given areas. So inverse normal, when we type it in, we have to type in the area to the left of the value you're looking for. Okay, for the newer calculators, it has more options, but we want area to the left. So we're going to type in 0.20, and then the mean, and then the standard deviation. So on the calculator where that function is, when you hit second distributions, it's the third option, inverse normal. It kind of reads the table backwards, I guess. So the area is 0.2. The mean was 38.72. Standard deviation of 3.17. Paste. And we get 36.1 approximately. So that means now we're given the height in inches. So the 20th percentile is about 36.1 inches. All right, next example. The scores earned on the math portion of the SAT, a college entrance exam, are approximately normally distributed with a mean 516 and standard deviation 116. What scores separate the middle 90% of test takers from the bottom and top 5%? In other words, find the 5th and 95th percentiles. So I've got the calculator steps here. Once you take a look and draw a diagram, the 5th percentile is the inverse normal of 0.05, mean 516, 116. That will give you the value here for x1. And then inverse normal 0.95, 516, 116 will give you the value up at the top. So let's go ahead and do that. We'll go back to distributions, inverse normal. The area is 0.05 for the 5th percentile. The mean in this question is 516. Standard deviation of 116. Paste. So 325 is the bottom score here. And then to find the 95th percentile, we put 0.95. Everything else remains the same. 706 or about 707. So the SAT math scores that separate the middle 90% are 325 and 707. All right, last idea is a notation, and this notation is tough. So we really I want to introduce it early. So the notation is Z with a subscript alpha. It's pronounced Z sub alpha. The definition, it's the Z score such that the area under the standard normal curve to the right of that value is alpha. So Z alpha means the area to the right is alpha. So find the value of Z subscript 0.10. That means that you're trying to find the Z-score with an area to the right is 0.10. So Z-scores go with standard normal. So a standard normal distribution has a mean of 0 and a standard deviation of 1. So mean of 0, standard deviation of 1. So to find the area to the right, or if we know the area to the right and we want the Z-score, we want to know how many standard deviations from 0 do we have to go to the right for an area of 0.1. So inverse normal is what we're going to use. We're using 0.90 because that's the area to the left. Remember, that's what the calculator wants. 0 is the mean, 1 is the standard deviation. So we would take inverse normal. The area is 0.9, area to the left. Oops, I got the wrong one here. I got the wrong distribution. You go to distributions, inverse normal. There we go. Oop, let me quit. When you get in a place you don't know how to get out of, just quit. So second distribution, inverse normal, area is 0.9. If you're looking for Z-scores, mean is 0, standard deviation 1. 1.28. So that means Z.10 is equal to 1.28. That means a Z-score of 1.28 has an area of 0.10 to the right of it. So let's take a look at a couple of examples from homework. Okay, so an example, fill in the blank. The notation Z subscript alpha is the Z-score that the area under the standard normal curve to the right of Z alpha is alpha. So the definition is on your homework. Find the value of Z subscript alpha. So this means that on the standard normal, with a mean of 0, standard deviation 1, find the value such that to the right we get an area of 0.06. So we have to use inverse normal, area to the left, which is 1 minus 0.06, mean of 0, standard deviation of 1. So we're going to use inverse normal. 1 minus 0.06 is 0.94. And that will tell us the Z-score. A Z-score, let's see. Distributions. The area to the left this time is 0.94. Mean of 0, standard deviation of 1. We end up with about 1.55. Okay, then you'll have some questions on homework that give you Z-scores. So we'll look at just A. A says, determine the area under the standard normal that lies to the left of Z equals negative 1.01. So draw a picture. Z-scores means we're using the normal distribution, and it's a standard normal. Area to the left of negative 1.01 is this area here. So when you're finding areas, it's normal CDF. The interval, negative infinity to negative 1.01, a mean of 0, and a standard deviation of 1. So we go to distributions, normal CDF. We're going from negative infinity to negative 1.01. Mean of 0, standard deviation 1. And we end up with an area of about 0.1562. Okay. So let me look at one more example. We'll look at chocolate chips example. Oh no, here we go. Number 24. The mean incubation time of fertilized eggs is 19 days. So we're given a mean of 19. Suppose the incubation times are approximately normally distributed with a standard deviation of 1 day. A, determine the 17th percentile for incubation times. That means on this distribution of 19 in the middle, 20, 21, standard deviation, determine the 17th percentile. That means I have an area of 0.17. So I want to find the fertilization times for an area of 0.17. So I'm going to use inverse normal, 0.17, with a mean of 19 and a standard deviation of 1. Okay, so we get inverse normal, area of 0.17, mean at 19, standard deviation of 1. We're going to paste 18.05. So the 17th percentile is 18.05 days. Right. So we're going to stop there. Again, StatCrunch does all of these same things. So if you want to try, view the videos in the notes, or they're in my math lab as well, then on the notes, notice you have a solution by hand, calculator, and StatCrunch. Please use either the calculator or StatCrunch.